Hi everyone, my name is Abner and I am master's student in industrial engineering with a focus on sustainable production. Today, I will be presenting our study on life cycle assessment and circular economy, in this case, a case study of the textile processing industry. This paper was authored by me and co-authored by Eduardo Campos, Gabriela Ruas, Gustavo Rocha, Virginia Mores, and Diogo Silva. In this study, we examined the environmental impacts and circularity of a textile dye process. Well, the Brazilian textile industry is the 50th largest globally, employing something like 1.34 million people and contributing 2% to the GDP, according to the Federation of Industries of the state of Goiás. Despite its economic importance, this industry faces challenges with operational efficiency and environmental impact, especially in processes such as spinning, weaving, and dyeing. Well, the environmental impacts are significant, particularly due to the waste generated, such as effluents contaminated by dyes and oils, and improperly disposed products. As a result, thousands of tons of textile waste are incorrectly discarded each year. Given these challenges, life cycle assessment emerged as a tool to evaluate and identify potential ways to reduce the environmental impacts throughout the production cycle. LCA, or life cycle assessment, is a methodology used to quantify the environmental performance of a product or service by analyzing material inputs and outputs to estimate potential impacts according to the ISO or International Regulation of Life Cycle Assessment. Well, several studies have suggested substituting certain raw materials with more sustainable alternatives. For example, Linhares and others discussed replacing synthetic dyes with a natural alternative derived from the bark of an invasive tree species, which reduced the overall environmental impact. Similarly, Costa and others compared synthetic and natural dyes in textile dyeing process, showing that natural dyes resulted in significantly lower environmental impacts. Other studies, such as Yuan and others, conducted an LCA on cotton fabric dyeing and identified water recycling and energy conservation as key strategies to mitigate impacts. Bianco and others highlighted that wool production had significant environmental impacts, emphasizing that the need for a holistic approach in evaluating the entire production chain. In other words, LCA here is a good alternative. In this context, our study applies LCA to a real case, aiming to raise awareness and propose sustainable practices to mitigate environmental impacts in textile process. Well, our study followed a structured approach. First, we assessed the company's sustainability maturity using the iGo platform, which provides a quantitative and qualitative assessment of resource efficient in small and medium sized enterprise or SMEs and suggested areas for improvement. This helped us to understand the company's uh, internal resource use. Well, besides that, we also conducted a SWOT analysis to identify the company's strengths, weaknesses, opportunities, and threats. Additionally, a pestle analysis was performed to examine political, economic, social, technological, environmental, and legal factors that might influence the business. Life cycle stakeholders, in other way, helped us to identify the most important stakeholders. Next, we calculated the company's circularity using the material circularity indicator from the Ellen MacArthur Foundation. Well, we analyzed two scenarios, the current situation and the future scenario with the proposed improvements, evaluating the effectiveness of the change. Well, the LCA, our main focus, followed the ISO standard and the regulation to life cycle assessment. Well, this ISO was 14040 and 14045. The four phases of LCA were goal and scope definition, life cycle inventory, life cycle impact assessment, and interpretation. We concentrated on four impact categories: long term climate change, water ecotoxicity, water scarcity, and water acidification. Well, we have here the scope, cradle to gauge, the objective that was evaluate the potential environmental impacts of processed fabric. The function of the system was to customize fabric according to client specifications, and the functional unity was 18 meters of processed fabric, and the reference flow 1 kilogram of processed fabric. Well, primary data were collected from company employees, these companies, while other unavailable data were sourced from LCA databases, the public databases, or literature. For example, energy data derived from biomass burning and others were obtained from Maya in a case study on LCA in a company of Textile. Well, in the LCIA phase, we used the Impact Word Plus method and the software Open LCA version 2.0.3. Well, by the end, a Canva business model was utilized in order to summarize the new business model. Finally, comparisons were made between the results obtained for the current state of the company and the proposed changes to analyze the system sensitivity to the suggested alterations, which included reducing the amount of detergent, dye, and chemicals used, as well as replacing detergent with soap. The central idea of these changes was to mitigate the impacts of chemical materials in the process, highlighted in the baseline scenario analysis as one of the system hotspots. Each of these changes was considered as a scenario with sub-scenarios based on actual reduction achieved, 10%, 20%, and 30%. In the end, a scenario incorporating all the proposed changes was suggested. Well, let's to the results and discussion. The IGO platform was used to assess the company's environmental performance in some areas like resource efficiency, energy management, water use, chemical use, and waste management. Overall, the company performed better than its peers, but areas such as chemical management and the waste handling still need improvement. Well, the SWOT analysis identified strengths such as investment in infrastructure, biomass, energy, and effluent treatment, but also point out weaknesses, including inconsistent systematization and measurement of sustainability efforts. Opportunities exist in improving energy and resource efficiency and reusing textile waste. However, the environmental impacts and evolving regulation pose significant threats. Well, uh, the pastel analysis showed that the economic factors like increasing GDP and falling unemployment rates could boost demand, while the growing sustainability agenda presents both challenges and opportunities. Technological factors highlighted the need for investment in water and energy efficiency, while legal and environmental factors necessitate compliance with stricter regulations and sustainable practices. Well, about the stakeholders, we identified that the stakeholders related to the company can be categorized into four types based on their association. We have here supply chain, personal interest, customers, and personal interest. Well, about supply chain, stakeholders include suppliers of paints, equipment, dyes, packaging materials, oil, other chemicals, and the company handling product transportation. Personal interest stakeholders are Sorocaba City Hall, employees, and universities, while personal interest stakeholders comprise employees, families, and nearby residents. Customers are the fabric producers and companies interested in purchasing leftover customized fabrics. Okay. Having identified the stakeholders, it's essential to consider how they can contribute to a more circular business. For example, paint suppliers can develop environmentally friendly paints that generate less waste. Universities can establish partnership to improve internal process and reduce environmental impact, while Sorocaba City Hall can provide tax incentives and fabric producers should raise customer awareness about the importance of environmentally friendly business practices and other possibilities also. Well, for the LCA, we used primary data that we collected from company employees, and this was the structure of the company. So we have the inputs, the process, and the outputs to the technosphere and the biosphere. Well, uh, the results showed that the main hotspots of the process are dyeing process, transport and receiving, and washing because of the use of chemical products, of the transportation, and the use of chemicals in the dyeing process also. Well, so aim to reduce these, as I said before, we made a sensitivity analysis with some proposals to have a better result in the process of the company. Okay, so we made some reducing in the use of chemicals, for example, and replace the detergent with biodegradable soap. So the results showed that the reducing of chemicals and the use of soap are the best alternatives in terms of reducing the overall impact. And if we can, well, make the improvements together, we have a really better result in terms of environmental impact, as we can see in this graphic. So we have a really good result in the synthesis scenario, that is the all the changes together, and we have all the synthesis 10%, 20%, and 30%. And we see that with 30% of reduction, we have the best result. Well, in conclusion, adopting sustainable practices in the textile industry, such as reducing harmful chemicals and replacing synthetic detergents with biodegradable alternatives, is essential to mitigate environmental impacts. While the reduction in environmental impacts were modest, the proposed changes align with a more sustainable and responsible business model. Well, this study highlights the importance of continuous efforts to improve sustainability in textile process, not only through technological innovations, but also by adopting circular economy principles. Future research should explore the impacts of transportation and use more specific data sets to enhance the accuracy of LCA analysis for chemical inputs. Well, that's it. Thank you for the invitation.